Welcome to the Research Analysis Center, the heart of computing, here at NASA Lewis. The Research Analysis Center, or RAC, provides scientists with the power to explore the future. From a stronger space shuttle to the futuristic National Aerospace Plane, our computers have liberated designers from the slow pace of endless calculation. Accelerating the pace of innovation, they have freed researchers to pursue new ideas. Increasingly, the only limitations are our own imaginations. Join us as we show you what high-performance computing is all about. A revolution is occurring in scientific research. It's called visualization. Our highly sophisticated approaches to today's challenges are often so complex they need supercomputers. Yet we're overwhelmed by the sheer volume of information supercomputers provide. Where we once relied on one-dimensional graphs, today the sheer scope of calculation can be far beyond our ability to assimilate. But when we can visualize and animate our data, we give information the power of life. At our state-of-the-art lab for graphics and advanced visualization, researchers gain new insight and physical intuition into the problems they study as they translate numbers into living images. Like a child negotiating an unfamiliar world, we learn to conceptualize by exploring the phenomena around us. Tracing the paths of particles, analyzing a dynamic range of color change, such as when we fly through this advanced multi-stage compressor, designed using supercomputer technology to replace costly prototypes that we would otherwise build, test, and remanufacture with every alteration in design. Here, the color changes capture when and how pressure builds to help us send engine performance to new heights. NASA scientific visualization expert Dr. Jay Horowitz.
Experiments that once took place inside of laboratories, wind tunnels, and out in space now take place inside of supercomputers. And not surprisingly, other computers, like these computer graphic workstations, now simulate the cameras, telescopes, and microscopes that the scientists use to study the phenomena. But in many ways, these workstations are more powerful. Scientific visualization allows the scientist to visualize those aspects of his data that he's really interested in, and pictures allow them to make sense of the millions and millions of numbers that the computers generate. Scientific visualization has become a critical tool for the scientists here at the center.
If the world of animation is the living embodiment of the new revolution in sophisticated research codes, supercomputers have made it all possible. So let's turn to the machines that are building this new world, starting with our premier architect, the Cray YMP supercomputer. NASA supercomputer expert Tony Hackenberg.
The critical thing about supercomputers is their speed. One way to portray this blazingly fast speed to you is that if I hold a flashlight approximately 10 feet away from a wall, this Cray YMP could multiply two 64-digit numbers and have the result before the beam of light reaches the wall. This blazingly fast speed is necessary in lots of applications around this lab. Perhaps the most important is the study of gases flowing through a jet engine. These calculations require trillions and trillions of adds, multiplies, and divides to be successful.
To meet the demand of speed, every supercomputer component is miniaturized. The circuitry of each chip is packed so densely, it's as if you could compress the entire street map of Cleveland on the head of a pin. Speed is essential, but so is long-term memory. To handle it, we rely on mass storage. Better than a library, our memory storage units hold the equivalent of 2,000 sets of encyclopedias. These super high-density cartridges are fetched and mounted by Edison, our robot, whose faster-than-human speed frees our operators for more challenging work, like working with data acquisition systems that gather the results of experiments run all across NASA Lewis. Supercomputers, mainframes, mini-computers. We house them all here, in a room the size of a football field, where we run scientific computations instead of football plays. Like any team, we generate heat, nearly enough to warm our building in winter. We've even designed a way to recycle that heat so we could use it year-round. All of our information requires networks to travel. And we're proud of our Network Operations Center, which keeps us connected to each other and talking around the world. Here, we maintain the integrity of our networks, monitoring connections, recording trends, troubleshooting problems. NASA networking expert Cal Ramos.
The impact of our computer networks here at Lewis Research Center has been tremendous. Our computer networks has given us the power to communicate with other researchers throughout the country and throughout the world. Networking is really one of the key enabling technologies essential in today's information-oriented society.
In the past 50 years, NASA Lewis has been a part of Cleveland. We've made an impact, from space shuttle propulsion to satellite communications. We're proud of all that we've accomplished, and we're looking forward to the 90s, where we'll be leading the development of power systems for space station freedom. By accelerating the pace of innovation, the Research Analysis Center stands behind NASA Lewis as we face the challenges to come.